Okay, quick reminder on how to do an inverse. A lot of times we call it a three-step process, but that's because oftentimes it starts with f of x. Well, this one already has a y there, and that's what you do as the first step, is change f of x into y. So, hey, I've already got the first step done. Next step is you reverse your x and your y. Now, the key element here is that that's what an inverse does. An inverse takes your x's and y's and flip-flops them. So we've got to take this y and rewrite it as an x, and take the x's and rewrite them as y's. There. Is it done? Well, I wish it was that easy. Now you have to get the y's alone, as in you have to solve for y. And what's complicated here is that there is two y's in that equation on the right-hand side. And so therefore, I'm going to start by multiplying both sides, like I usually advise, getting the fraction out of here. I'm going to multiply both sides by y minus 7. And that way I won't have the fraction anymore. Now I'm going to multiply this out, and I will have xy minus 7x equals 2y. In order to have a chance of getting y alone, I have to get all the y's onto one side. So next I'm going to subtract 2y from both sides. And now I have xy minus 2y minus 7x is equal to 0. Now I'm going to add the 7x to both sides, and I will have, let's jump underneath, I will just move this part down. We will have xy minus 2y is equal to 7x. Remember what your goal was. We don't want to try to solve for x. We already had that way up here in the blue equation. We wanted to solve for y. So, trying to get y alone here. And one of my favorite sayings comes into play. If you can factor it, you should. The y's get factored out to the outside, and you'll have x minus 2 equals 7x. And then divide both sides by x minus 2. And y is alone, and it's equal to 7x over x minus 2. Now what did I just do there? I built a inverse. My original equation was right up here, y equals 2x over x minus 7. And now I have y equals 7x over x minus 2. Really might have been nice to call this f of x, and we could now call this like g of x or something. So they are definitely different functions, and they are inverses of each other. If you graphed them, they'd be a reflection across the line y equals x. That's one thing that's true. And generally speaking, the x's and y's have been reversed. So if this point, if the point, let's say 2, 8 had been on that graph, then this would have the point 8, 2 on it, because the x's and y's get reversed. All right, there's the reminder on getting inverses. You swap x and y, and then you solve for y again. That's all I have for you on that.